Hello students, once again welcome to the maths class. Today I am going to explain properties of inverse t functions. T functions means trigonometric functions. First property is self-adjusting property. What is this property? You understand carefully. It is written sine inverse sine theta equals theta if theta belongs to the closed interval minus pi by 2 to plus pi by 2. You can say here sine inverse and sine will cancel. For the convenience of students, we say sine inverse and sine will cancel and theta will remain. But they are not actually cancelled. They are adjusted themselves with a method. That method you can see in the book. But here for the convenience you can keep in the mind sine inverse and sine they will cancel. Theta will remain. In the same way, cos inverse cos theta equals theta if theta belongs to 0 to pi. One more thing here, you pay attention students, they will cancel and theta will remain if theta lies, it is written, theta lies with a particular range 0 to pi, and here it is written minus pi by 2 to plus pi by 2. These are, in last video I told you, particular ranges of inverse trigonometric functions, and they are called principal ranges. If theta lies in the principal ranges, then you can apply directly self-inverse, self-adjusting property. Otherwise, you cannot apply this property. If theta does not lie in this interval, you cannot apply directly self-adjusting property. In the same way, tan inverse tan theta equals theta if theta lies in the particular range. So others you can see cosec inverse cosec theta equals theta. Here you come now in second column. In second column, sine is outside, sine inverse x is inside. Here what is the difference? Sine inverse was outside and sine function was inside. Here sine is outside, sine inverse is inside. But they will adjust themselves here also. Sine and sine inverse they will cancel, x will remain. But again condition is there, x must belong to the closed interval minus 1 to 1. For different trigonometric function, different intervals are given. So if they are not, particular intervals are given. These particular intervals, if your x is not lying in the particular interval, then you cannot apply this self-adjusting property. Cos inverse x equals x if x belongs to minus 1 to 1 in the closed interval. Tan inverse x equals x for all x, means if x is any real number, then directly you can write x. In the same way, cosec inverse x equals x for all x belongs to minus infinity to minus 1 and 1 to infinity. In the same way, other you can see. Now one example I will take in which you cannot apply directly self-adjusting property. So you see here this example, cos inverse cos 7 pi by 6. Since 7 pi by 6 does not lie in the closed interval 0 to pi, this is the particular range for inverse trigonometric functions of cos. So it is not lying this 7 pi by 6 because it is greater than pi. So it is not lying, it is outside this interval. So first of all, I will make this angle so that it should lie in this interval, then I can apply self-adjusting property. So cos 7 pi by 6, it is a positive term, and cos is positive in first and fourth quadrant. In class 11th you have studied. First quadrant we cannot apply because this angle is greater than pi. So with the help of fourth quadrant we can write this angle 7 pi by 6 as 2 pi minus 5 pi by 6, because after solving this 7 pi by 6 you will get. Now cos 2 pi minus theta equals cos theta. In class 11th you have studied cos 2 pi minus theta equals cos theta. So with the help of this property you can write cos 5 pi by 6. Now this 5 pi by 6 is the angle which lies between 0 and pi. So you can apply self-adjusting property and you can write answer 5 pi by 6. Now you see some more examples are there. This first example, sine inverse sine pi by 3. Pi by 3 lies in the particular interval that minus pi by 2 to plus pi by 2. So directly self-adjusting property you can apply and answer will be pi by 6. Here cos inverse cos will cancel and answer will be 2 pi by 6 because 2 pi by 6 lies between 0 and pi. Here also tan inverse and tan will cancel and pi by 10 will be the answer. But this fourth part you can see here. In the fourth part it is given, you can see fourth part here. This is the fourth part. Sine inverse sine 5 pi by 6. 5 pi by 6 does not lie between minus pi by 2 to plus pi by 2. So what will you do? First of all, you will correct this angle. You will see 5 pi by 6. You can apply sine 5 pi by 6, sine pi minus pi by 6. With the help of 11th class, you know very well. Sine pi minus theta equals sine theta. So sine pi minus pi by 6 equals sine pi by 6. So 5 pi by 6 I have converted into pi by 6. Now in place of sine pi by 6 I can put sine pi by 6. In place of sine 5 pi by 6 I can put sine pi by 6. Then self-adjusting property answer will be pi by 6. In this way you can solve all the parts of this example. Now one more example I am taking. This example you can see. Second column I showed you in table, in first table. So here sine is outside, sine inverse is inside, and one value is given. So this value should be between minus 1 and 1. So you can see this 2 upon 5 is between minus 1 and 1. So you can apply self-adjusting property and answer will be 2 upon 5. Here any real number should be there. Self-adjusting property in case of 10 you can apply, then answer will be 23 upon 18. But in third part you can see, in third part sine cos inverse 3 upon 5. To apply self-adjusting property, sine inverse should be there, but it is not sine inverse, cos inverse is there. So first of all you take this inside part as theta. Cos inverse 3 upon 5 equals theta. So cos theta equals 3 upon 5. Then trigonometric ratio. With the help of trigonometric ratio, this 3 is base and this 5 is hypotenuse. Here they are writing in the figure, they are giving wrong. This perpendicular they are giving 3. Perpendicular they are giving 3 and base they are giving 4. Base will be 3 and perpendicular will be 4. So and hypotenuse is 5. So with the help of, by Pythagoras theorem you can find hypotenuse 5. So with the help of this figure you can find sine theta equals 4 upon 5. Then theta will be sine inverse 4 upon 5. Theta means you know cos inverse 3 upon 5. So cos inverse 3 upon 5 equals sine inverse 4 upon 5. So in place of cos inverse 3 upon 5 you can put sine inverse 4 upon 5. Here you can see, and that self-adjusting property you can apply. So answer will be 4 upon 5. Next point is coming. Second property, reciprocal property. What is reciprocal property? Cosec inverse x can be written as sine inverse 1 upon x. But condition is given, x must belong to real number except the values between minus 1 and 1. Then only you can write cosec inverse x equals sine inverse 1 upon x. In the same way, sec inverse x equals cos inverse 1 upon x. Again condition is there, x must be a real number except the values between minus 1 and 1. Then you can write cot inverse x equals tan inverse 1 upon x if x is greater than 0. Condition is there. And pi plus tan inverse 1 upon x if x is less than 0. So these things you have to keep in the mind. If in the question you want to convert, if any need of conversion is there, so you can apply this reciprocal property and you can convert. But condition you have to remember, x must belong, in first case x must belong to any real number except the values between minus 1 and 1. Next property is coming. Examples also I will take based on these properties, but first you understand all the properties. So, theorem number 3 or property number 3. Sine inverse minus x can be written as minus sine inverse x. Again condition is there, x must belong to the closed interval minus 1 to 1. Tan inverse minus x minus tan inverse x, x belongs to real number. Sec inverse minus x equals pi minus sec inverse x, and x must belong to any real number except the values between minus 1 and 1. And cosec inverse minus x minus cosec inverse x, and x must belong real number except the values between minus 1 and 1. And here also two conditions are given. So these properties you have to learn. In the question they can be applied if they are needed to apply. Next property is coming, very important property. You can see sine inverse x can be written as directly cos inverse under root 1 minus x square. Just before I converted in previous example, cos inverse 3 upon 5, cos inverse 3 upon 5 equals sine inverse 4 upon 5. In previous example I converted this. So you can, with the help of triangle I converted this. If you don't want to take, if you don't want to make triangle, then directly with this conversion property you can write sine inverse x equals cos inverse under root 1 minus x square, or with the help of triangle if you find, then also you will get cos inverse under root 1 minus x square is equal to sine inverse x, you will get with the help of triangle also. Otherwise you learn these properties as I'm telling to you. And tan inverse sine inverse x equals tan inverse x upon under root 1 minus x square. Sec inverse 1 upon under root 1 minus x square. Cot inverse under root 1 minus x square upon x. And cosec inverse 1 upon x. Just before I told you property fourth. So like this all properties are given. Sine inverse you can convert in other inverse trigonometric functions. Cos inverse x you can convert into other inverse trigonometric functions. Tan inverse you can convert into other inverse trigonometric functions. These three properties are given, so you have to learn. If you learn, it will be good for you. Next, one more property is coming, theorem number 4, that was theorem number 5, and previous to theorem number 5, that was theorem number 3. Sine inverse x plus cos inverse x equals pi by 2. Students, you have studied in class 10 sine inverse sine square theta plus cos square theta equals 1, such type of property. Similar to that, sine inverse x plus cos inverse x equals pi by 2, but condition is there, x must belong to the closed interval minus 1 to 1. Tan inverse x plus cot inverse x equals pi by 2, it is also pi by 2, but x must belong in this case to real number. And sec inverse x plus cosec inverse x is also pi by 2, and x must belong to real number except the values between minus 1 and 1. Now some examples I am going to take so that you can understand these properties well. So this example number 10 you see. In this example, find the value of sine inverse into cos 33 pi upon 5. First of all, self-adjusting property you cannot apply, because outside sine inverse is given and inside cos is given in place of sine. And one more thing, this angle, whatever angle is given, this angle should be in the range minus pi by 2 to plus pi by 2, but it is not there. So first of all we will make this angle short. How can we make? You can resolve this angle. You can write 6 pi plus 3 pi by 5. If you solve this, then 33 pi by 5 will come. So 33 pi by 5 can be written as 6 pi plus 3 pi by 5. Now cos 6 pi plus theta, cos 6 pi plus theta, cos theta. This is the property in class 11th you have studied. Cos 2n pi plus theta equals cos theta. Now angle you have made short, but you can see this 3 pi by 5. 3 pi by 5 if you calculate in degree, so it will be 108 degree. 5 was a 5 and 5 it's a 18 3 is a, no, it is the angle 3 into 180 upon 5. 5 3s are 15, 5 6 are 30. Yes, 108. I was saying correct. So this is not the angle between the range minus pi by 2 to plus pi by 2. So again, what can you do? You can write this angle pi by 2 plus pi by 10. When you solve it, so 3 pi by 5 will come after solving. And cos pi by 2 plus theta. So it is in second quadrant. Cos pi by 2 plus theta. So minus sine theta will come. Because you are working in 90 degree. So it means that this trigonometric ratio will change. Cos will become sine. And whatever angle you are adding, that will come. But with negative sign, because this angle lies in second quadrant. So now this sine inverse minus x, I told you just before property, sine inverse minus x equals minus sine inverse x. So it can be written as minus sine inverse sine pi by 10. Now you can apply self-adjusting property. Self-adjusting property, sine inverse will cancel with sine, minus pi by 10, because it belongs to the closed interval minus pi by 2 to plus pi by 2. So like this example you can solve. Many questions will be there in the exercise of such type. So you can solve those questions. But you have to understand this example properly. Next example is coming. You can see next example. Evaluate tan inverse minus 1 upon root 3 plus cot inverse 1 upon root 3 plus tan inverse sine minus pi by 2. How can you evaluate? First of all, you have to remember this. Tan inverse minus x minus tan inverse x, sine minus theta minus sine theta. And apply this. Tan inverse minus 1 upon root 3 can be written as minus tan inverse 1 upon root 3. It is same. And tan inverse sine minus pi by 2 minus sine pi by 2, it can be written as. And tan inverse again minus x minus tan inverse x you can write. And tan inverse 1 upon root 3. 1 upon root 3 is the value of pi by 6. Pi by 6 means 30 degree. And 1 upon root 3 in cos, it is the value of pi by 3. So you can write pi by 3. And this sine pi by 2 value is 1. So you are writing 1. So minus pi by 6 plus pi by 3 minus tan inverse 1. And tan inverse 1. So in tan, this 1 value for the angle pi by 4, it is there. So now minus pi by 6 plus pi by 3 minus pi by 4, you simplify it, pi by 12, answer will come. So like this you can solve. One more example I am going to take. This is the example. You can see here 12 example. Prove that sine big bracket starts, cot inverse curly bracket starts, cos round bracket starts, tan inverse x equals under root x square plus 1 upon x square plus 2. So how can we solve it? You see, this is first part. First of all, cos tan inverse x you take. So tan inverse x, first you convert tan inverse into cos inverse. How can we convert? Conversion property just before I told you. Tan inverse x equals cos inverse 1 upon under root 1 plus x square. Now apply self-adjusting property. Cos and cos inverse will cancel. Answer will be 1 upon under root 1 plus x square. Now in place of cos tan inverse x, you can put 1 upon under root 1 plus x square. You can see here, in place of cos tan inverse x, 1 upon under root 1 plus x square. Cot already it is given, cot inverse. Now you can see after this step, now cot inverse I have to convert into sine inverse. So directly you can apply that conversion property, or if you don't want to apply, then you can make the triangle, and with the help of triangle you can find this. This cot is base upon perpendicular. So base is 1 and perpendicular is 1 under root 1 plus x square. You can see here. Here you can see base is 1 and perpendicular is under root 1 plus x square. By Pythagoras theorem, hypotenuse will come under root 2 plus x square. Now you can see, so this sine inverse will become perpendicular upon hypotenuse. Perpendicular is this one, under 1 plus x square, and hypotenuse you have found 2 plus under root 2 plus x square. Now self adjusting property you can apply, so your required result will come under root x square plus 1 upon x square plus 2. Now second part you can do yourself. One more example I am going to take. Theorem number 4 I told you, that was the theorem sine inverse x plus cos inverse x equals pi by 2. So the use of that theorem in this example you can see. This is the question: sine inverse cos sine inverse x plus cos inverse sine cos inverse x equals pi by 2. You have to prove. LHS can be taken. Now you see here, in place of sine inverse x, I have taken pi by 2 minus cos inverse x. So with the help of that theorem, sine inverse x plus cos inverse x equals pi by 2. So sine inverse x equals pi by 2 minus cos inverse x. By applying that theorem, I am writing this. In the same way, by applying the same theorem, cos inverse x can be written as pi by 2 minus sine inverse x. Now cos 90 minus theta, cos 90 minus theta, you know very well sine theta. So sine theta is cos inverse x here, and here sine 90 minus theta cos theta. Theta is sine inverse x here, so cos theta you are writing. Now self adjusting property you can apply. So sine inverse sine cancelled, cos inverse cos cancelled. So it will remain cos inverse x plus sine inverse x. And by applying again fourth theorem, cos inverse x plus sine inverse x equals pi by 2. So these were the uses of the theorems which I explained. I hope you have understood all the properties of inverse trigonometric functions, and you can solve all the questions, not all the questions, the questions related to these properties from exercise 4. So for today it is enough. Thank you and have a nice day.